Welcome to GoToWebinar Made Easy.
We will be demonstrating our ePHASORSIM solution, the real-time transient stability solver. Now here on GoToWebinar control panel, you will see on the left side of the menu a left arrow with the hide button, microphones muted, where we will be holding our questions post-presentation. So at the end, we will have plenty of time to delve into questions and answers. So you will be remained on mute status, as well as we invite you to click the raise your hand icon, and we will accept your written questions as well, typing in your question directed to the staff. Excellent. Your hosts today, myself, your moderator, Darcy Laronde, Business Development here at OPAL-RT Technologies. Our first presenter, Dr. Fabio Aires, Software Developer here at OPAL-RT Technologies. We welcome you. Our second presenter, Dr. Vahid Jalili Marandi, our simulation specialist and ePHASORSIM specialist here at OPAL-RT. Thank you very much for joining us. We do have a special guest joining us as well throughout the presentation. That will be Kevin Heng Chen, a power system engineer at Electric Power Group. And last but not least, we will have our CEO and CTO, Mr. Jean Belange, joining us for the post-mortem question and answer session. Our agenda today, ladies and gentlemen, will consist of introduction, features, applications, future developments, a live demonstration, our ETAP partnership, RTDMS EPG, being the Electric Power Group, and finally our question and answer session. Briefly, OPAL-RT Technologies was established 16 years ago, 1997. We enjoy a strong R&D turnover of 20%. A lot of leading-edge technology puts us on the cusp year after year. We are a large and diversified customer base worldwide, operating in over 55 countries. As well, OPAL-RT is your one-stop shop for model-based engineering simulators consisting of power electronics and systems, as well as catering to the automotive, aerospace, educational, academic sectors. Our specialties do lie within RCP, Rapid Control Prototyping, and HIL, Hardware in the Loop Simulations. And we are pleased to say that we are fully integrated with MATLAB Simulink. As you can see here, our partial customer list does consist of Hydro-Quebec, ABB, Sandia National Laboratories, GE Global Research, National Renewable Energy Labs, and so on. That wraps up our brief introduction, and without further ado, I'm going to hand the floor over to Fabio.
Thank you very much, Darcy. I am Fabio Aires. I am a software developer here at OPAL-RT, and it is my pleasure to discuss with you in this webinar our ePHASORSIM product. The problem we are trying to solve, we are achieving with ePHASORSIM is the simulation of electromechanical transient stability phenomenon in real time. Now, what is then the electromechanical transient stability phenomenon? What we are concerned in this problem is the simulation of electromechanical phenomena. So that is, Phenomena that occur due to electromechanical disturbances and that have a duration, a transient duration in the range of seconds. Those phenomena can cause problems with the stability of the power grid. In order to observe this phenomenon, and especially the instability that can result from an electromechanical disturbance, we have to study the power grid in a large scale. We have to see the system as a whole. And we would like to verify what is the effect of a transient stability event in the power grid together with the rest of our systems in real time. Therefore, it is important to understand how that phenomenon will play out in relation to our controllers, our SCADA systems, and so on. And that's where real time plays a big part. So I believe we have a question right now.
Yes, we're going to take a brief pause and address our first poll question. This question stands as what would be your main application of fast transient stability simulation tools? There is a 4 multi-choice option here. 1, development and hardware-in-the-loop testing of wide area control and transmission systems. 2, operator training simulators. 3, development of faster than real-time instability detection tools. And 4, development of hardware-in-the-loop test of local wide area control and distribution systems. We'll give you a moment to address this question. Thank you.
Thank you very much. Let's proceed with our presentation today. So, ePHASORSIM is inserted into a spectrum of solutions that we provide here in OPAL-RT technologies that cover your entire spectrum of needs for power grid simulation. ePHASORSIM.
Welcome to GoToWebinar. Webinars made easy.
Tens of thousands of nodes in real time. When you want to perform a simulation with a higher time definition, you can count on our solutions such as HyperSim, eMegaSim, where you can simulate electromagnetic transient phenomena with time steps in the range of microseconds. And furthermore, for those who have a need to simulate power electronics with very high time definition, RTLab also offers the FPGA Sim solution, in which the time step can go as low as tens of nanoseconds. The ability to have all these solutions integrated is another strong point of ePHASORSIM. So what is ePHASORSIM then? ePHASORSIM is our real-time transient stability simulator. It has been designed from scratch to address the issue of simulating large-scale power grids in real time. ePHASORSIM has also been designed to be able to handle problems of transmission system simulation, distribution, and generation. ePHASORSIM is a phasor type of simulation, is a phasor domain solution. That is, given that we are interested in phenomena in the range of seconds with a time step in the range of milliseconds, we are therefore modeling the entire phenomena around the nominal frequency of the network. And we are modeling the entire problem using the well-known concept of phasors. We model the power grid either in positive sequence, as it is customary for transmission system studies, or in full unbalanced three-phase when we want to model a distribution system. And as I mentioned before, the time step then for the simulation is in the range of a few milliseconds. In ePHASORSIM, you get to describe your power grid in either a simple Excel form from a template that we provide, or as a PSSC raw and DYR files, version 32. These are the forms of data input for ePHASORSIM. You can then place ePHASORSIM in the context of a larger RT-Lab simulation model. You can place a Simulink block in the middle of your RT-Lab simulation, as it is customary for RT-Lab users. You can indicate that the input should come from one of these possible sources, and you use the rest of the facilities available at Simulink to connect to the scopes and the other components and other Simulink blocks, and to also, through RT-Lab solutions, you would be connecting to analog IOs, to digital communication protocols, and so on. All of that simulation will be then executed in one of our simulation targets, which will then run inside the ePHASORSIM solver, and you will be able to observe the results of your simulation in a multitude of ways, such as scopes or our test drive solution, or, as we are going to demonstrate later, we can even send those results to a full SCADA system. To give you an example of the data input, it is a very simple set of tables with well-recognizable parameters for the practitioners of this field. The point being that with ePHASORSIM, once you describe your network and you set up your simulation, ePHASORSIM will allow you to achieve anything you would like to do with transient stability simulation at its heart. What can you achieve with ePHASORSIM? You can develop a full operator training simulator with ePHASORSIM. We can use ePHASORSIM to test your SCADA system, communicating using standard industrial protocols. You can develop your own models in ePHASORSIM and integrate them within a larger network to study the effects of your model, say, of a controller or a protection scheme or a new power system device, and see how that plays out within the context of a large power grid. You can use ePHASORSIM to analyze cybersecurity scenarios, power security situations. And you can also run ePHASORSIM in a faster than real-time mode and develop solutions for prediction, real-time prediction of power system security, where you can take your current state of the power grid and run it, fast forward it in time to see what your power grid may look like in the immediate future. Therefore, the idea of constructing ePHASORSIM was the realization that we have a gap, a technological gap, in the existing tools for power system simulation. On one hand, we have the tools that allow you to perform large-scale power grid simulation, in which you can do planning and you can do design and you can test offline the consequences of certain actions, of certain events. Such tools are well known, such as Eurostag, SIME, PSSC, and ETAP. On the other hand, you have the real-time simulators, which allow you to study electromagnetic transient phenomena where the time step is in the range of microseconds, such as ePHASORSIM and HyperSIM. In that scenario, you can study smaller power grids, but with a very high time step definition. We realized that a gap exists between these tools, and that's what we want to provide with ePHASORSIM, where we allow you to simulate both in real time and with large power grids.
Thank you, Fabio. This brings us to our second poll question. The question being, what dynamic transient simulation tool are you using? Again, 4 selections here: PSSE, second, Dig Silence, GE PSLF, or another. We'll give you a quick moment to participate in this second poll. Thank you.
Thank you, Darcy. So moving on with our presentation here. Now, one of the most important characteristics of ePHASORSIM is its real-time performance. Oh, I'm sorry, apologize. As I said before, ePHASORSIM has been designed from scratch with high performance in mind to be able to simulate large-scale power grids with milliseconds time step. Here is an illustration of our performance, which has been obtained by running our simulator on a single CPU core with a time step of 10 milliseconds. And I want to call your attention to case number 2, in which you can observe that we perform a simulation of about 10,000 nodes with 2,500 generators, close to 5,000 controllers, and 18,000 other components such as loads and transmission lines. And for that size of the grid, we obtain a simulation performance between events, between faults or switching events, of 3.28 milliseconds of real computation time for a 10 milliseconds simulated time, which places us well within the real-time range for such a large network. During the occurrence of a fault or a switching event, the extra calculations required to maintain the state of the network brings us to a computational time of 7.4 milliseconds, still well within the 10 milliseconds of simulated time, and therefore we maintain real-time capacity even during switching events. In case number 3, we have an even bigger network of 20,000 buses, 20,000 nodes, and 5,000 generators. In that case, between the simulation of faults and events, we have a computational time of 6.6 milliseconds, well within the real time, but our time during faults may exceed the real-time requirements. So in conclusion, we can run comfortably 10,000 buses and be within real time at all instants, or we can run even 20,000 nodes, but occur an overrun penalty at the moment of a fault, but only then, no further. ePHASORSIM has a large and growing library of models to allow you to model whatever problem you need to address. Our models consist of generator models, realistic generator models, or just simple voltage sources, constant impedance, constant current, and constant power load, transmission line models, excitation system models, stabilizer, turbine and governor assemblies, and transformer with tap changer, reactors, capacitor banks. We have the ability to integrate user-defined models developed in Simulink, and to integrate ePHASORSIM with SimPower system controller blocks as well. In terms of the actions that can be triggered in the network, we can have balanced and unbalanced faults. We can have open connector conditions, line tripping. We can have generator outages, fault on transmission lines at any point of the line, load shedding and restoration events, tap changing events, automatic voltage regulation adjustments, reclosing commands, loss of excitation, and many more. ePHASORSIM, I'm sorry, at this point we are going to take another poll question.
Thank you, Fabio. And on that note, we will address our third and final poll question. Quite some impressive real-time performance here. And speaking of performance, this question lies within what should be the capability of the transient stability simulation tool in terms of nodes, the number of nodes that can be simulated in real time within 10 milliseconds. Under 1,000 nodes, between 1 and 5,000 nodes, 5 to 20,000, or 20 to 200,000 nodes. We'll give you a moment to address this last poll question. Thank you very much, and back to you, Fabio.
Thank you, Darcy, and thank you for the participants for answering these questions. They are quite useful for our own assessment and future development here. ePHASORSIM, ePHASORSIM, as I said before, has a very advanced computing capability, and it runs in real time, which means that in order to obtain the biggest benefit from ePHASORSIM, you can also count on our open and scalable hardware platform, which allows you to integrate the simulations that are being performed with ePHASORSIM together with many communication protocols and analog IOs that you encounter in our hardware products, such as the OP5600 series, the OP700 series, and so on. So with ePHASORSIM, you can interact with SCADA systems and with synchrophasors and with energy management systems through standard industrial protocols such as DNP3 and C37118 and OPC. You can also communicate physically with devices using analog IOs and digital IOs as well. You can also, the entire simulation runs in one of our targets, communicating with your host computer, so your communication can, the simulation can be performed on your desktop and accessing remotely our chassis, and that gives you a lot of flexibility for your own developments. ePHASORSIM also integrates with a host of test automation and visualization platforms, such as our own product Test Drive, which allows you to implement realistic control panels in LabVIEW and connect directly to signals being read from or sent to our simulator. You can connect with a scope view, which gives you a sophisticated way to record, display, and analyze the results of your simulation. And you can automate your tests using Python. So, all of that capability allows you to develop many different applications. And in order to give you an idea of what can be done with ePHASORSIM, here are some of the situations of ePHASORSIM in action, some of our technological showcases and collaboration with partners and clients that have resulted in success cases here. In this slide, I show you a simplified version of the Hydro-Quebec power grid being simulated in ePHASORSIM. What you see in this slide is a panel that was constructed in test drive, which allows us to trigger events into the simulation and visualize those events in a separate panel in test drive, or, as we will show later in the demo, we can actually communicate all of this action and those simulated signals through standard communication protocols to the RTDMS product of the Electric Power Group company. We have developed in conjunction with them a technology showcase that we will demonstrate later. So as you can see, we can send the results of triggering a fault and clearing that fault, visualize them. In partnership with another client, we have developed as well a simulation of a distribution feeder and interfaced that simulation using DNP3 for phasor data concentrator testing. We have also, as I said before, developed a technology showcase in partnership with the Electric Power Group, in which we are connecting the simulated signals coming from ePHASORSIM to the RTDMS tool, which then sees these signals as if they were real synchrophasor signals in the field. And therefore, you can test a large-scale deployment of RTDMS in a very realistic scenario. As I mentioned before, we can generate phasor data, synchrophasor data. And any application that would rely on synchrophasor data can be tested with ePHASORSIM, therefore. Here's an example in which we were able to connect our synchrophasor data being generated from ePHASORSIM directly to the open source PDC manager product. We are working as well in partnership with ETAP to create a real-time simulation platform in which we can develop, validate, and demonstrate smart grid solutions. ETAP's products such as automatic generation control and intelligent load shedding will be connected to an ePHASORSIM simulation of a representative network. And with this setup, smart grid solutions will be tested and evaluated under several what-if scenarios. In this pilot project, we can see here an illustration of what we are achieving with this pilot project. We have an ETAP model in which the signals an ETAP model that is connected to an OPAL-RT system. For those who are familiar with ETAP, you would be able to monitor the simulated signals coming from the OPAL-RT system directly on the ETAP console. The OPAL-RT system communicates as well with the ETAP server via OPC. And the ETAP server containing the automatic generation control application will then provide control commands, control actions to the OPAL-RT simulation in order to obtain optimal generation deployment. And all of those simulation results can as well be visualized in the ETAP solution. So as you can see, ePHASORSIM is the heart that allows you to perform all of your studies relying on simulation, on the large-scale power grid simulation. And we are glad to have at this point the participation of our collaborators, our partners, the Electric Power Group, which will talk a little bit about their solution, RTDMS, and a little bit about the scenarios envisioned by both of us for future applications using ePHASORSIM and using RTDMS. Our guest is Kevin Chen, Power System Engineer from the Electric Power Group, and I therefore cede the floor to you, Kevin.
Thank you, Fabio. Can you hear me?
Yes, we can hear you.
Okay. Hello, everyone. This is Kevin Chen from Electric Power Group. I'm the product manager of RTDMS. Here is our state-of-the-art synchrophasor monitoring and visualization application. Today, I'm just going to briefly walk you through some of the RTDMS platforms, and I'm going to show you a simulation video demo of the recent Pacific Southwest blackout, and then talk about the integration scenario with ePHASORSIM, as well as some key RTDMS applications. To start with, so this is just a high-level overview of the RTDMS platform. You can see from left to right, we have the data source available. So we're envisioning the RTDMS not only just for synchrophasor, but also it's a comprehensive platform which can integrate phasor data, SCADA data, geospatial information, and also some weather, such as lightning and information. Then all this data will be put into our platform, and then we have a host of different applications there. First, we can do some data quality checks and data validation and conditioning, and also then we can stream the data into power system analytics applications such as mode meter, voltage stability, etc. I'll talk about later. And then further down, all the data, the raw data and the calculated data will be saved into our database and further provided to the visualization client for the user to visualize. So next, so I'm going to show you the case study we did. This is the September 8th, 2011 Pacific Southwest blackout. We simulated this case using GE PSLF simulation tool, and then we transferred the data into a live stream with the C37118 protocol into RTDMS. For those of you who are not familiar, NERC and FERC public report on the blackout, and we used all the information in the report to generate the video simulation. So as you can see, this top chart is I obtained from the report. You can see there's the 7 stages during the blackout, and you're looking at there's a substation called Sounds, and this is the current out of the Sounds coming from to the south of the Southern California area. And then the top chart, the bottom chart is the corresponding simulation result from RTDMS screenshot. So now I'm going to show you the video demo. So here it just first it shows you the timeline of the span of 15 minutes. You can see when the serious event has occurred, and then correspondingly it leads to the system overload, and finally, eventually, it leads to the San Diego blackout. And during pre-event condition, you can see from the RTDMS dashboard on the geospatial map, everything is green. And then during the second phase, which just has the Yampa North Gila line tripped, then you can clearly see that once the line tripped, here the arrow shows the angle difference between the two areas. You can see the alarm colors are changing. There's alarm on the alarm panel for angle difference as well, because the system is is stressed. So if we can zoom in into that area and see there's several paths overloaded. And if you use the trend chart, you can also see there's a huge angle difference jump between the two areas. And the corresponding current also overshoots. The next phase, when the Coachella Valley transformer tripped, the system gets stressed further. You can see the angle difference increase as well as the current out of the zone. When the next event happens, it did some load shedding, but it didn't help much. You can see the dropped a little bit, but still it's in very high loading condition. And when the UMA load positary drops, the system gets stressed further. You can see it's around 7,000 amperes on that path. And finally, when the currents overshoot 8,000, there's a remedial action to treat all of the lines south of sun, and then leads to the system collapse. And right now, you can see the angle difference between the Arizona area to San Diego is really high. It's above 100 degrees. And here we have the blackout. So we can see when you have the blackouts, current goes to 0, and the system separates. Okay, back to the slide. So what we really did is, for this scenario, is using GE offline simulation, and then we convert it to real-time into RTDMS, and then we can do a list of analysis using the platform. But with the partnership with OPAL-RT, what we can do is, actually Vahid is going to show you a demo, is that we can simulate the large-scale power system using ePHASORSIM simulation, and using the real-time simulation results, you can directly integrate into the RTDMS platform to realize your result, your different actions, and then get your feedback. So just for a quick overview, some of the applications here at EPG, you can see there's from wide area situational awareness to automated event analyzer, which basically identify generator trip, load shedding events, etc. on the fly. And also we have grid stress monitoring, frequency stability, oscillation analysis, and reports. So this slide shows you a quick overview of the eastern interconnection. This is using real PMU data. You can see the angle difference across different areas, indicating the high level of system stress. And next slide, this shows the mode meter application monitoring ambient oscillations, which gives you the estimation of modal frequency, damping, and energy level, along with the other visualizations for the associated information. For the record, we have 2 similar video demos on YouTube. You are welcome to check it out. So that's all I have. Thank you very much. I'll pass it back to Fabio or Vahid. Thanks.
Thank you very much, Kevin. And now we proceed with a demonstration of the use of ePHASORSIM integrated with RTDMS, and I will therefore cede the presentation to Vahid.
You can hear me now? Yeah. Okay. Thank you, Fabio, and thank you, Kevin, for your nice presentation. What I have here is 2 demos I will show you. One is for the modeling of the Hydro-Quebec transmission level system in the province of Quebec in Canada. That this demo will show that which type of the control options or the maneuver options we have to monitor and control, and also do the measurements with ePHASORSIM. The panel that I will show here is made in LabVIEW that is integrated with ePHASORSIM with our test drive tool. And the second demo that you will see is about the PMU and system monitoring. As Kevin explained it in the previous, in his talk, that because ePHASORSIM, the data which are available are in the phaser mode. So it acts like that you have PMUs at every place in the location. The only thing that you need to do is to extract the data and send and wrap them in the in the C37 protocol, and then it's available that you can send them to the any data concentrator like a PDC or any synchronous phaser software application like open source code like OpenPDC. And in this demo, what I have used is the RTDMS tools from EPG Group, EPG Corporation, and I am using the same network from Hydro-Quebec. I assume that I will have 10 PMUs in different locations in the province. I gather the data and send them to the visualization client. Okay, so okay, so what you are seeing here is the test drive panel, which is shows the which is only a graph that shows the signal line diagram of the simplified Quebec system. We have Montreal in the south, Quebec. We have Churchill and also James Bay generation unit. They are connected through the transmission line, the transformer, and there are different type of the loads. In the right-hand side, you are seeing the monitors that I placed there, so we can monitor some. I have chosen to have some parameters to monitor, for example, the rotor angle of the synchronous machine, the frequency of the system, the voltage of each pass. As also, you can see them in the figure with the red on the red phones. Also, you can see the current flow on the transmission line with the green green line. You can have access to very internal parameters of the simulation, like a excitation reference voltage or the input of the mechanical input of the synchronous machine. So just to have an idea that how this model is integrated with ePHASORSIM, I will show you the what it looks like in the back behind the scene. Here is the general model that we have for RT Lab. So this block, which is called solver, this is the main bullet. This is the heart of the ePHASORSIM. What you will do is that if you click there, you can see you can integrate it. You can link it with an Excel file. Here we can have PSSE file or the Excel, both PSSE or Excel file. But here I'm using the Excel file. You put a timestamp that it is the timestamp, which is in this case is 10 milliseconds. I just briefly go through the Excel file to give you an idea how it looks like. As you can see, it's a very simple template that it has multi tabs, and you can describe your network here. You have the page for bus, for example, machine, for the controller of the exciter, system stabilizer, and several other things. In the so if I go back to the my test drive model here, you can apply, you can have several maneuver operations. For example, I want to see that what happens if I apply a fault at this bus. So I can do that, and you can see that in real time the simulation reacts, and you can monitor all the parameters that you have chosen to see. I will remove the fault. Or, for example, if I want to see what happens if I open a line between a connection between two bus sections, or I can apply the fault on the line. For example, here I apply the fault and I can change the location of the fault. Now it is in 50% of the lines, and with this bar I can change the location, and then you can see that what is the reaction there. Also, I can, I have other examples here. For example, the change of the position of the transformer tab. For example, here I want to change the position by 10% in the Churchill power plant. Or I can also increase or decrease the value of the loads. For example, in the Quebec, I want to do a load shedding, or I do a load shedding like just to make it 0, and then I do a load restoration and bring back the load. So all of these can be done. Actually, there are much more than this, but I have just selected some of them for the presentation. So the next demo is that we are having the same system, but what we do is that I'm sending the ePHASORSIM's data, wrap them in with the C37 protocol, which it's provided in RT Lab, and then these data the data which is wrapped here can be sent through the ePDC. ePDC is a product with from EPG. Then here I have selected that I will have the PMUs in 10 locations like Quebec, Montreal, Manic, the base station, Churchill, and other. So here we can monitor the data. We see that we have 100% of data availability. We can check that if the data quality is good or no. And the next step that we can send these data from the PDC to the visualization client. So just to have an idea that how this visualization client look like. Actually, you saw the video that Kevin showed you in his talk, but this is the live demo that you are seeing here. Here it is the Montreal station. We have Quebec. We have Churchill here, and we have the James Bay station. The PMU location, if you go in the PMU location, you can see the voltages, the angle difference. In the other, you can have several the different type of the views. For example, here I have the frequency of the system, and in this one I have the power which is transferred between between transmission lines. But the favorite one of everybody is normally this view is that you exactly see that what is the RMS value and angle. Actually, you are seeing the phasor data here very live. So, for example, if I want to send an operation command from my test drive, I just open the line which is between the Quebec and Montreal, and then I will look at it at how it looks like in the visualization client. Okay, you see that when that happens, the voltage and angle of the buses are changing, the frequency is changing. So because this is actually is a kind of the disturbance, a big disturbance in the system, they are out of synchronism, and you can see more signals like the voltage waveforms, the current transferred, and also we can have more other type of the tabulated or just digital views of the system. So these what I'm showing here are just for monitoring, but RTDMS tools has some other application that you can do more analysis like the sensitivity or the load frequency deviation, but they are not shown in this demo. Also, you can have a tabulated view of the data that you have here. Okay, that's all that I have for this demo, and thank you all for listening to me.
Thank you very much, Vahid. Sorry, there we go. Thank you very much, Vahid. So with this, we conclude our ePHASORSIM presentation. I would like to leave you with a few concluding remarks. As we have seen in this webinar, ePHASORSIM provides you with real-time hardware-in-the-loop simulation. ePHASORSIM allows you to investigate large-scale power grids with unprecedented performance. ePHASORSIM gives you the flexibility to develop your own applications and studies, and it integrates with the entire power grid family of solutions, which allows you to model effects from the transient stability simulation range all the way down to the power electronics range. So, thank you very much. I hope you have enjoyed this presentation, and we'll cede the floor back to our host, Darcy.
Thank you very much, Fabio. I want to thank everybody for participating in this webinar today. Vahid, thank you. Fabio, thank you. And Kevin, our guest speaker, thank you very much. Noteworthy, ladies and gentlemen, is the fact that OPAL-RT will be at the upcoming Distributech conference in lovely San Antonio, Texas, January 28th through the 30th. end of the month, please visit us at booth 327. More information can be found at our website, www.opal-rt.com. Another upcoming event is our real-time user conference being held here in Montreal, June 9th through the 12th, RT14, Real-Time 14. More information can be found by emailing realtime@opal-rt.com. Please, we invite you to register now online at the below mentioned address, RT14. Okay, we have some questions here. Let's see what we have here. If we're introducing faults and if it's conducting cascading impacts on the network, can we simulate the same using ePHASORSIM?
Can you hear me? Yes. Yes, after the prediction of a fault, the simulator will continue on to simulate the various effects that are taking place on the network at that moment. If the occurrence of a fault results in a further disturbance of the system that happens to trigger a protection event elsewhere, that event will also take place and the simulation will also continue from that moment on. So we do not stop at a fault moment, we continue on the simulation. I hope that has answered the question.
Yes, thank you, Fabio. Next question we have from Peter. I was wondering if you plan any work with Modelica and ePHASORSIM. I'm seeing a great benefit.
Thank you very much for this question. Developing your own models is usually a very difficult task. So instead of having to develop your own power device or controller or protection scheme directly in C++ or Transient, we would like to give users the ability to use a high-level mathematical model such as Modelica to be able to develop your own components. We are right now in the final stage of development of that feature. And what we would like to give you is the ability to develop models with Modelica and export those models as functional documents, which can then be driven by the ePHASORSIM simulator. So yes, we certainly would like to integrate user-defined models in Modelica.
Thank you, Fabio. Next question from Mr. Saxena. Can we do hybrid simulation, EMT phasor, in the same MDI file? Yes, we can hear you.
Yes, actually we can do, and we have tested ePHASORSIM to do both hybrid simulation. The phasor part is done in the ePHASORSIM, and the EMT part is done in the with the SPS sim power system blocks in the Simulink MATLAB. The time step in EMT part was 50 microsecond, and in phasor type was 10 milliseconds. So we have tested these, and we are able to do.
Okay, we have time for one more question. You want to add something, Joe?
Just to add that this feature of simulation EMT and ePHASORSIM is very complex. So what we did as of now is a simple prototype, but we are accelerating the development of more complex interface.
Thank you. Fortunately, we have time for one last question, or fortunately. Do you offer ePHASORSIM on different parallel processors to increase even more the number of nodes?
Right now, ePHASORSIM runs on a single core. Even with a single core, we already achieve a very high level of performance as shown today.
However, we do understand that even further performance may be required for certain users. And in that case, yes, we are also with the development of high-level capabilities to extend further performance of ePHASORSIM in our development schedule to be
Thank you, Fabio. So, we'll take one more question here. Coming from Danielle. Do you simulate the positive sequence only, or are you capable of doing a full three-phase simulation? In the latter case, are you able to achieve the same speeds?
the schematics that I gave are for the number of nodes. So if I have a three-phase simulation, simulated in full three-phase mode, you have to consider that we're talking about nodes, not buses. So you would have to divide that number by the number of phases. But having that said, we do offer full three-phase simulation as well.
Terrific. Thank you, Fabio. That's terrific, gentlemen. Kevin, can you hear me? Is there anything you would like to add?
I just want to thank you very much for inviting me to present. So we do have a variety of applications beyond the RTDMS. We also have a data concentrator as well. So we're looking forward to partnership with ePHASORSIM and achieve some other projects as well. Thanks.
We thank you, Kevin. All right, that wraps it up for today, ladies and gentlemen. Feel free to visit us at www.opal-rt.com and reach out to us for any additional questions you have or discussions you would like to pursue. Thank you for joining us.